Oh, okay. What we're going to do here is just to show you a little bit about sliders and how they work so you can start playing with them with quadratic functions. Here, what I want to do is just play with them with linear functions. So I'm going to go up here and try to type in an equation. I'm going to write y equals m times x plus b. Now, normally we'd see a line, but it doesn't know what m is, and it doesn't know what b is. And you can see what it says over here. It says add slider. Well, let's just talk about what happens when we add a slider for each. I'm going to click on all. And you can see it added a slider for m, it added a slider for b. Now what that means is, for example, at the moment, m is 1, b is 1, so I'm actually looking at the equation y equals x plus 1. And you can see that it's graphed here, which is awesome. Now, the reason they have sliders is we can actually use the sliders to change what's going on a little bit. Now, I'm going to change b a little bit first. I'm going to go over here, I'm going to slide it to the right a little bit. And you can see that every time I slide it up a little bit, I change the equation a little bit. So I'm changing the y-intercept. You can see the y-intercept's going up. Now let's make the y-intercept go down like this, back and forth. We're good. All right. Now, the kind of expression I want or reasoning I want from you from the quadratic functions is, for example, with b, is when I change b, the graph moves up and down, but the rate of change of the graph doesn't change at all. When I look at how fast this line is going up and I change b, I get a different line that goes up at exactly the same rate. So changing b here doesn't change the rate of change at all. Now let's go put b back a little bit. Wonder if I can type it in here. I can. Yay, I'm happy about that. All right, so now what I'm going to do is go start sliding m. Now m is the slope. Now if I slide m, you can see that the point, the y-intercept does not change. So what I'm doing is just giving different lines that go up at different rates, but still go through that one point. Now when m is much bigger, you can see that the rate of change is very large and positive. When m is smaller, you can see that the rate of change is lower, 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 lower. This line hardly has any rate of change at all. It's almost zero. If I try to go up here and just type in 0, yes, there's a line that has no rate of change at all, right? The y values never change no matter how x changes. So here I have 0m. If I make m negative, I can see that I get lines whose rate of change is negative. These are rates of change that are very, very negative. These are rates of change that are barely changing at all. If I can actually do this, yes, what I want, just a little bit to the right. There you go. I get a line that still goes through that point, right? So when I leave b alone, that point doesn't change. But when I change m, the rate of change changes a lot. This is the kind of thing I'm going to ask you to do for quadratic functions. I'm going to ask you to change a, I'm going to ask you to change h, I'm going to ask you to change k, and describe then what changes about that parabola when I change each of those things. And you're going to use the sliders and a little exploration to find that out.